In this example, we are looking at the end behavior of a graph, and we're comparing the different graph shapes to see which one will grow the fastest over time. All right, so if we think about a linear graph, all right, a linear graph is known about having a constant slope. That's what makes it a line, right? It travels in the same direction forever and ever and ever and ever. All right, now a quadratic graph, it has a slope that is changing. All right, now it is changing constantly with an exponent of 2. All right, so that means you're taking whatever x value is going in there and you're timesing it by itself. You're multiplying it by itself. Now, if you have an exponential graph, all right, exponential graphs also changes constantly with an exponent of x. All right, so if we want to think about over time which one will grow the fastest, as long as these are all trending in a positive direction, the exponential graph has to grow the fastest because this has an exponent of 1, this has an exponent of 2, and this has an exponent that's a variable. It's constantly increasing and getting larger. So exponential graphs always grow the fastest. All right, so I'm going to pull up a picture of Desmos here to give you some examples. Oh, my Desmos isn't fitting nicely on the screen, so I'm just adjusting a little. There we go. So this first equation is linear, right? It has x to the first power. You can see as I look at it here on the screen, that exponent being 1 causes it to just be a flat line. Here's an example of a quadratic, right? You can see here at the bottom, at the vertex, it has a slope of 0, and then it increases over time. And then here you see it's super flat, right? And then it just shoots off in another direction. And so what we're trying to do is we're trying to compare these three over time. So what I'm doing here is I'm going to adjust my window settings. All right, I'm going to go from 0 on the y-axis, and we'll go from -10 on the x-axis to, oh, I don't know, +10. Stretch it out a little bit. That looks nice. All right, so you could see right down here that these guys all kind of humble mumbled together, right? So the linear out the gate, this linear, because it has a constant slope, isn't starting at 0 like the quadratic is at 0. All right, and here the exponential has a little bit of a slope to it, but it might not be nearly as much as the linear one, right? You could see that blue line is above the other two here. So for a moment, this linear graph is slightly faster in terms of its growth. But then you could see that very quickly the tables turn, don't they? And this exponential graph, this purple one, grows out to being the top. So as I move towards positive infinity, this thing is just growing super, super duper fast. And that purple one stays on there. See how it's the steepest over time? And so that's what we mean by exponential graphs growing the fastest. So if I'm really zoomed in for just an iota of a second, that linear one is surpassing the others. But then it does not take much time for an exponential graph to just shoot up and take over in terms of the fastest rate of growth over time.